Hello, everyone. Welcome to Sleep Space. Tonight, we'll talk about something mysterious and strangely comforting, the idea that the universe might remember you. Go ahead and settle in. Let your body relax and your mind begin to drift. There's nothing you need to do right now. Just listen gently. Tonight, we're exploring what happens to your presence, your energy, and your influence once a moment has passed. Does the universe keep a record of what you've done? Can it store memories the way we do? Or is that just something our human minds project onto the cosmos? Let's begin with a quiet truth. Nothing in this universe is ever truly lost. It changes, it transforms, but it never disappears. When you move your hand through the air, you displace molecules. You create turbulence. That movement affects particles around you, which go on to affect others. Even the warmth from your body radiates outward as infrared light, and that light travels. Some of it will eventually hit the walls around you. Some will be absorbed, but some will escape. It might pass through the window and move upward, through the atmosphere, and out into the vacuum of space, traveling forever at the speed of light, carrying a trace of you. Photons, don't forget. Once set in motion, light carries information about what it touched, its angle, its energy, its timing. This may sound poetic, but it's not just metaphor, it's physics. You are constantly sending out information into space, into matter, into time itself. When physicists talk about the conservation of information, they mean that what happens in the universe is never erased. The particles may rearrange, but the information remains. It's part of the structure now, encoded, translated, distributed. In this sense, the universe may remember everything it's ever been, not like a person remembering a birthday or a dream, but as structure, as evolution, as cause and effect rippling endlessly forward. This is where science becomes almost spiritual, because it suggests something profound. Everything you've ever done continues, in some form, forever. Your voice, your movements, your choices, they all leave subtle fingerprints on reality. Imagine this. You take a deep breath. The air enters your lungs, fills your chest, oxygenates your blood. You exhale. That air, those molecules, leave your body. They spread out into the room. They mix with other air. Some of those molecules will eventually rise, pass through a vent, drift into the outside world. They'll be carried by wind currents across continents. They may be breathed in by someone else, or rise even higher into the upper atmosphere. They might last for hundreds or even thousands of years, moving, changing, continuing. In this way, even something as small as a single breath becomes part of Earth's story. And Earth's story is part of the universe. The same is true for light. When you step outside in the sun, sunlight touches you. Photons strike your skin, and when you move, you reflect light back out. That light carries a shadowy trace of you. It leaves Earth. It travels outward. Some of it may one day pass a distant star, or be absorbed by dust in deep space, or perhaps continue forever into the darkness. This isn't fantasy, this is what light does, and it means that in a very real way, you are still moving through the universe. A part of you is always on the way to somewhere. Now, you might ask, does this mean the universe is watching? That it has consciousness? Not necessarily, but it does mean the universe is structured in a way that keeps records, whether it means to or not. Black holes, for instance, are famous for this paradox. For a long time, scientists believed that anything falling into a black hole was lost forever, but that violated the principle of information conservation. So physicists proposed something stunning. The information doesn't disappear. It gets smeared across the surface of the black hole, the event horizon, like a cosmic hard drive, encoded, flattened, preserved. Stephen Hawking once suggested that the information is still there, just scrambled beyond recognition. And if that's true for the most destructive force in the universe, then maybe it's true everywhere. Maybe the entire universe is, in a sense, a memory field. Not conscious, not intentional, but persistent, eternal. Everything we do echoes, changes the arrangement of particles, alters the quantum state of fields, and those changes ripple outward endlessly. Let's bring this down to earth. When you speak, your voice vibrates the air. The sound travels in waves, hitting walls, bouncing off objects. Those vibrations get absorbed, but not perfectly. Some of that energy lingers. Some of it is converted into heat. Some of it gets scattered into the environment. In a quiet enough place, with sensitive enough instruments, you could, in theory, detect faint traces of sound long after it's been spoken. Of course, in practice, the signal gets buried in noise, but the principle holds. No sound is ever truly erased. It's just diluted. Now scale that idea up. Think of every movement you've ever made, every decision, every heartbeat. All of them sent out signals, physical, chemical, energetic, that changed the world around you, slightly but measurably. And those changes led to other changes, and so on. Your entire life has been a continuous stream of influence. Like a pebble dropped into a still lake, the ripples spread out. At first visible, then subtle, then invisible, but still moving, still affecting. So, does the universe remember you? Maybe not the way you remember a friend's smile, but in its own way, yes. Through physics, through continuity, through the unbroken chain of cause and effect that stretches from the beginning of time to this very moment. You are part of that chain. Your presence is encoded in the structure of everything that follows. And perhaps that's enough. Perhaps that's all memory ever really is. The continuation of influence. A record etched into the evolving fabric of the cosmos. You don't need to hold on to anything. You don't need to prove your worth. Just by being here, you've made your mark. The universe has felt your presence, and it will never be quite the same. As you begin to drift into sleep, let that idea soothe you. Nothing is ever truly lost. Not the moments, not the memories, not you. You've left ripples in time, and those ripples will go on forever. What does it really mean to say that the universe might remember you? Not just poetically, but scientifically. What would remembering even look like in a universe without a brain, without a mind, without a self? To understand this, we have to step outside our usual way of thinking. In everyday life, memory feels personal. We remember birthdays, faces, words, emotions. It's tied to the brain, to neurons, synapses, electrochemical signals. But memory, at its core, is just the preservation of information. It's the ability to retain structure over time. And in that sense, the universe might be remembering everything, all the time. Information is a strange thing. It isn't made of stuff. It's not a substance you can touch, but it's real. It describes how matter is arranged. It gives context to energy. It tells us how the parts of a system fit together. In physics, especially in quantum theory, information is treated with deep respect. There's even a growing belief that information might be more fundamental than matter or energy themselves. That reality is built out of relationships, not things. That what something is depends on how it's measured, how it's observed, how it interacts. This idea leads us to something powerful, that the universe might not just contain information, it might be made of it. Every particle has properties: position, momentum, spin. Those properties carry data, and when particles interact, they exchange information. They change each other. They store traces of that interaction. Over time, these traces build up. The present moment becomes a collection of past interactions encoded in the state of everything around us. The result, a reality that is constantly recording itself. Think about this for a moment. The atoms in your body were forged in ancient stars. They carry the signature of nuclear fusion, billions of years ago. When you breathe, you're inhaling atoms that were once part of oceans, mountains, animals, people. Each molecule has a history, an unbroken path through space and time. It remembers, not in a conscious way, but through its structure, through where it's been and what it's done. The same is true of light, gravity, magnetism. Forces move, matter shifts, energy flows, and all of it leaves an imprint. Now imagine zooming out. Picture the entire universe as a vast, four-dimensional block, space and time woven together into a single shape. In this view, known as the block universe model, the past, present, and future all coexist. There is no flowing river of time, no ticking clock moving events forward. Instead, time is just another dimension, like height or width. Every moment that ever existed still exists, just at a different coordinate in the structure. Your childhood is still there, in some far corner of space-time. Your last thought, your next dream, they're all part of this eternal geometry, unfolding not in sequence, but in completeness. This doesn't mean you can go back and change anything, but it does mean that the record exists. The structure holds, and in that structure, your entire life is preserved, not as a memory in a mind, but as a real, enduring part of the universe's shape. This view aligns with Einstein's theory of relativity. According to relativity, there is no universal now. Time moves differently for different observers. What is the present for you might be the past or future for someone else, depending on how they're moving through space. This means that time is not absolute, it's relative, and that makes the idea of all moments existing together much more plausible. It suggests that your life is not just a fleeting flash in the dark, but a strand of light woven into the fabric of eternity. Let's go deeper still. In quantum mechanics, particles don't have definite properties until they're observed. They exist in a state of probability, a wave of possibilities. When an observation is made, the wave collapses into a specific outcome. But here's the mystery. That outcome becomes part of the universe's history. It affects what comes next. It leaves a trail. A measurement isn't just a snapshot, it's a transformation. It writes something new into the world. This is where quantum memory comes into play. Some systems, called quantum computers, can store and process information using these strange wave-like properties. Unlike classical memory, which is fixed, quantum memory can hold superpositions, multiple possibilities at once. And those possibilities don't vanish. They stay entangled with each other, connected across space and time. What if the universe works the same way? What if every particle interaction stores information in an entangled, distributed way? That would mean the universe isn't just a container for events, it's a dynamic, self-writing system. A cosmic memory network. A place where every interaction leaves a trace, where every change is stored in the quantum fabric itself. This brings us to something truly beautiful. The idea that nothing is forgotten. Even the smallest whisper of reality, every flicker of light, every shift in motion, every breath is encoded in the ongoing unfolding of existence. Even if it's buried, even if it's scattered, it's still there, still part of the record. This isn't just theory. In recent years, scientists have discovered that information is conserved even in black holes, the most extreme objects in the universe. For decades, we thought black holes destroyed information, that once something fell in, it was gone forever. But newer theories suggest that the information gets encoded on the surface, the event horizon, and can be recovered, at least in principle. This means that even at the edge of reality, memory persists. And if it persists there, it probably persists everywhere. So when we ask, can the universe remember you? We're really asking, does anything you do matter in the grand scheme? Does the trace of your life endure beyond the moment? And the answer, as far as physics can tell us, is yes. Yes, it does. Maybe not in the way we expect, maybe not with emotion or meaning or recognition, but in form, in cause, in consequence. You are part of the pattern now, woven into it, echoed through it. As you begin to drift deeper into rest, let's gently explore the idea that the universe itself might be built not just from matter or energy, but from information. This isn't science fiction. It's a real, growing idea in physics and cosmology. And it just might explain how the universe can hold on to everything that's ever happened. To begin, let's ask a quiet question. What is something, really? When you hold a rock, what makes it what it is? Its weight, its shape, its atoms, all of those are real, yes. But those atoms are mostly empty space. The particles inside them are not tiny marbles. They're more like fluctuating probabilities. So what gives the rock its structure? The answer is information. It's the way those atoms are arranged, the relationships between particles, the pattern. Information is not energy, and it's not matter, but it describes how energy and matter behave. It tells you how to put something together. Think of a snowflake. Every snowflake is made of the same material, frozen water. But the reason each one is unique is because of the information in its formation. Temperature, humidity, air currents. These shape the crystal. If you could describe the exact conditions in which it formed, you could recreate it. That description is information. In the same way, you are not just a collection of atoms, you are a pattern, a system of systems. The way your cells function, the way your brain lights up, the way your heart beats, these are all expressions of information. And that information, scientists believe, never fully disappears. It transforms, it disperses, but it's still there, encoded in what it changed and in what came next. This brings us to an extraordinary concept in physics called Landauer's principle. It states that erasing information requires energy. That means when a system forgets something, it must pay a physical cost. Even memory loss has consequences. It's not free. This ties information to the very fabric of thermodynamics, the rules that govern heat, motion, and time. It means that information isn't just abstract, it's physical. It has weight, not in the way a stone does, but in its connection to energy and entropy. Now consider this. If erasing information takes energy, and the universe is constantly trying to conserve energy, then it would be more efficient for it to keep the information, to store it, to weave it into its evolving structure. And this is exactly what we observe. In the movement of galaxies, in the orbits of planets, in the behavior of particles, everything follows rules. Those rules are information, and the way systems evolve depends on where they came from, their past states. That's memory. Even in a simple physical process, like a pendulum swinging, information is preserved. The position and speed of the pendulum at one moment determines where it will be the next. You can't separate the present from the past, and if you know enough about the present, you can calculate what came before. In theory, if you had perfect information about every particle in the universe right now, you could reconstruct its entire history. That's how deeply information is embedded in reality. But of course, things aren't that simple. In the real world, systems are incredibly complex. Entropy increases, things get more disordered. But even then, the information isn't lost. It's just harder to extract. It's diffused, spread out, mixed into the background, like ink in water. The pattern is still there, it's just hidden. And this too is part of the universe's memory, a deep, subtle record of everything that has ever been. This leads us to a remarkable idea known as the holographic principle. Some physicists believe that all the information in a region of space can be described by what's on its boundary. That means, in theory, everything happening inside a volume, like a room, a planet, or even a black hole, can be encoded on its surface, just like a hologram. This is more than metaphor. It's a serious proposal for how reality might work at the quantum level. And it means that the universe may store information not just in the things themselves, but on the edges between them. Imagine standing in a quiet room. You look around and everything seems still. But hidden within the air, the walls, the light, is a vast ocean of invisible information. The molecules remember the last time you spoke. The photons remember what they last bounced off. The gravitational field remembers where the mass once was. The structure remembers how it got here. Even if we can't see or measure all of it, the record is there. And that record includes you, your body, your voice, your choices, your energy. You have left a trail, not just through memories and photos and conversations, but through physics. Every movement altered something. Every word moved air. Every thought had a footprint in your biology, your breath, your heartbeat. And that biological change led to physical change. And so the chain continues. You've interacted with the world and the world has responded. It has changed because of you. It's humbling to think that even long after we're gone, the information we contributed might still echo through the cosmos. That some photon carrying your reflection might be on its way to a distant galaxy. That some molecule from your breath might still be floating, thousands of years from now. That the structure of a conversation, or a touch, or a dream might still be embedded in the subtle arrangement of atoms somewhere in the future. This is cosmic memory, not like a book you can open or a video you can replay, but like a fingerprint left on time, a signature etched in motion. And perhaps that's what remembrance really is. Not recollection, not nostalgia, but presence, continuity, the fact that you happened and the universe knows it because it became something different in response. As you rest, imagine the darkest place in the universe, a place where gravity is so strong that not even light can escape, a place where time itself slows to a near stop. This is a black hole, and it may be the clearest proof we have that the universe never forgets. Black holes have long been the great mystery of space. They begin when a massive star collapses under its own gravity. If the collapse is powerful enough, it creates a singularity, a point of infinite density, surrounded by a boundary called the event horizon. Once something crosses that line, it cannot return, not even light. For many years, scientists believed that anything falling into a black hole was gone forever, that it was swallowed and destroyed. But that belief created a problem, a deep contradiction in physics known as the black hole information paradox. You see, quantum theory insists that information cannot be destroyed. No matter what happens to a system, the information about its previous state must still exist. But general relativity, the theory that describes black holes, said otherwise. When matter falls into a black hole, it seems to vanish. So which is it? Can information be lost or not? For decades, this question puzzled the greatest minds in science. Then came a radical new idea. What if the information doesn't fall into the black hole at all? What if it stays right at the surface? Scientists began to suggest that all the information about what enters a black hole is somehow encoded on the event horizon. That thin boundary around the black hole acts like a memory screen. As matter and energy fall in, their properties are projected onto this surface, like a shadow or a hologram. This idea, developed by physicists like Stephen Hawking, Leonard Susskind, and Gerard Twee Hooft, changed everything. It suggested that black holes might be perfect cosmic memory devices, that even though you can't retrieve what's inside, the information is still there, smeared across the edge, preserved, hidden, waiting. And over time, as the black hole evaporates through a process called Hawking radiation, that information might slowly leak back out. Changed, scrambled, but not destroyed. Imagine that for a moment. The most extreme, mysterious object in the universe, once thought to be a void, a place of total forgetting, might actually be one of the universe's most reliable archives. It doesn't erase, it transforms, it compresses, but it keeps the data. Now let's step back and think about what that means. If black holes preserve information, then the universe must be designed to remember. Even in the most violent environments, the past is not deleted, it's rewritten into a new form. That rewriting isn't always obvious. It's not like a library you can visit, but it's real, and it points to a deeper truth, that memory, at the level of physics, is not optional, it's a requirement. This brings us back to you, to the quiet idea that everything you've ever done has left a mark. Your thoughts, your voice, your presence. These things interacted with the world, and the world, in response, changed. That change continued forward, touching other things. And even if you can't trace it, even if you'll never know where those ripples go, the physics suggests they're still there. So now imagine your own life as a kind of personal event horizon, a boundary where everything you've experienced is etched, not in light, but in influence. The people you've helped, the words you've spoken, the kindness you've given. These aren't just emotional memories, they are physical events. And physical events are remembered by particles, by light, by fields. They are encoded like stardust on the skin of time. It's strange to think that black holes, these distant, terrifying objects, might actually reflect something gentle, something reassuring, that nothing, not even light, is ever truly lost, that every photon falling inward carries information, that every piece of matter becomes part of a deeper record, and if that's true in the heart of a black hole, it may also be true here, in your everyday life, in your room, in your breath. We often imagine memory as fragile, fading, but at the cosmic scale, memory is persistent. It's in the gravity of the earth, the rhythm of your heart, the molecules in your skin. All of these are part of an unbroken story, one that began long before you were born and will continue long after. You are not a moment. You are a continuation. Even your thoughts have effects. When you feel something, love, joy, sorrow, your body responds. Chemicals are released, neurons fire, muscles shift. These physical responses ripple outward. They influence your posture, your words, your actions, and each of those influences something else. Like light caught in a mirror, bouncing endlessly forward. This is the quiet miracle of the universe, that you cannot touch the world without leaving a trace. And that trace is remembered, even if it's scattered, even if it's quiet. It lives in the patterns that come after. Close your eyes and imagine something even smaller than atoms. Picture particles so tiny that they don't behave like anything you've ever seen. In this strange world, rules bend, logic softens, and time, space, and certainty dissolve into probability. This is the quantum realm, and here, memory takes on an entirely different meaning. Unlike the predictable orbits of planets or the steady ticking of time, the quantum world is full of uncertainty. Particles exist in multiple states at once. They flicker between being and not being. A single electron can travel many paths simultaneously. But here's the strange part. When something observes it, it chooses. The wave of possibilities collapses into one outcome, one history, one record. It's as if the universe makes a note. This is what happened. This is what's real. This moment of collapse, the measurement, the observation, marks a kind of quantum imprint. The system leaves behind a fingerprint of what occurred, and this record influences what comes next. Even if it's invisible, even if you can't detect it directly. Information, once created, doesn't simply vanish. In fact, the universe won't let it. That's the rule of unitarity in quantum physics. The total information in a closed system remains constant. No matter how chaotic things get, the memory is preserved. Now imagine billions of quantum events happening around you every second. Photons bouncing off your skin, molecules vibrating with your breath, your heart generating electromagnetic fields. Each interaction marks a quantum moment, a tiny collapse, a shift from potential to actual. And somewhere in the deep fabric of the universe, these tiny notes are kept. Not like a diary, not like a hard drive, but like a web of interlinked outcomes woven into the quantum field itself. Let's take it further. Think about entanglement. This is a strange and beautiful quantum phenomenon where two particles become linked. No matter how far apart they go, their states remain connected. Measure one, and the other instantly reflects the change, even across galaxies. Einstein called it spooky action at a distance. But it's real, and it tells us something profound. Information is not local. It's shared. It echoes through the universe, invisibly binding parts of reality together. So now ask yourself, if particles can remember each other across the void, what else is remembered? If your body is made of particles, if your brain is a quantum system, then your very thoughts and actions participate in this great entangled web. You are not separate from it. You are part of its memory. Each time you made a choice, the world shifted. The wave function collapsed, and that collapse echoed forward, threading through time in subtle, complex patterns. This is the idea behind quantum decoherence. When a quantum system interacts with its environment, its wave function becomes entangled with everything around it. It no longer behaves in isolation. It becomes part of the world, and even though you can't reverse it, the imprint is still there, embedded in the correlations, like ripples on a pond long after the stone has sunk. Even temperature holds memory. Heat is a measure of motion, of particles bouncing off one another, exchanging energy. Each interaction changes something, and those changes accumulate. They define the present. They shape the possible futures. Thermodynamics, the science of heat, reminds us that even disorder, even randomness, is the result of prior conditions. Nothing is random without a cause, and causes always leave evidence, however subtle. Now relax your thoughts and picture your own life through this lens. Every step you've taken, every breath, every glance, all of it is woven into the quantum field. Not in a way you can look up or replay, but in the deeper structure of reality. You've changed the world in ways too vast to measure. A smile that changed someone's day, a word that shifted a decision, a presence that calmed a space. These are quantum effects too, tiny interactions magnified through time. You don't need to remember it for it to exist. The universe already does. The particles that made you are still here. The photons you've touched are still traveling. The energy you've released is still moving through space. It's all part of the quantum imprint, a soft, invisible memory scattered across the cosmos. And this brings us to something beautiful. You can never be erased. Not truly. Not completely. Even as your form changes, even as time carries you forward, your presence remains encoded in the energy you gave, in the changes you caused, in the interactions that unfolded because you were here. This isn't just poetic, it's physics. It's the quiet law beneath the chaos, that every effect has a cause, and every cause leaves a trail. And though we may never decode that trail, it exists. You exist. You've left your quantum mark on the universe. Close your eyes and picture the universe as more than just stars and planets. Imagine it as a vast, invisible fabric, soft, flexible, and flowing. This is space-time, a four-dimensional stage where space and time are not separate, but woven into one continuous reality. And in this fabric, memory may be stored in ways we are only beginning to understand. When we talk about the memory of the universe, we often think of information or particles. But space-time itself has structure. It can bend, it can stretch, it can ripple. Massive objects like stars or black holes cause it to curve. And just as a handprint in sand holds the shape of what touched it, the curves of space-time hold the shape of what passed through. Motion leaves memory. According to general relativity, gravity is not a force pulling things together. It's the effect of curved space-time telling objects how to move. And every mass, every movement, every burst of energy changes that curve. So in a very real way, the path you've walked, across your room or across your life, has gently tugged on the fabric of the cosmos. That change may be tiny, infinitesimal, but it exists. A whisper of motion recorded in the geometry of reality. Now consider gravitational waves. These are ripples in space-time caused by extreme cosmic events, black holes merging, neutron stars colliding. These waves carry information. They travel across the universe, stretching and squeezing space as they pass. When we detect them, we are reading the memory of an ancient, violent moment, a cosmic echo, and if those great events leave ripples, then so might all motion in far subtler ways. Some physicists believe that the universe contains what's called a causal structure. This is the idea that events are linked through the order of time, that every cause leads to an effect, and every effect traces back to a cause. The pattern of these links forms a web, like a cosmic memory map, not just of what happened, but of when and how everything connects. Even more mysterious is the possibility that black holes, those dark, silent objects, store the ultimate memory. For decades, scientists thought information was lost inside them forever. But Stephen Hawking changed that. He proposed that black holes slowly evaporate through a process called Hawking radiation. And if that radiation contains information, then nothing is truly lost. It's scrambled, yes, transformed, but still there, still part of the universe's record. This leads to something called the holographic principle, a bold idea in modern physics. It suggests that all the information contained in a volume of space can be described by data encoded on its boundary, like a hologram. Imagine that your life, your choices, your existence could be written not just in your body or your memories, but in the edges of space-time itself, in the surface of the universe. You are not just in the universe. You may be etched into it. Even time itself may preserve memory. The arrow of time, the reason we remember the past but not the future, is deeply tied to entropy. Entropy is the tendency of systems to move from order to disorder, but every increase in entropy is a record of what came before. Like footprints in snow, the present state of the universe contains hints of the path that led here. So while you lie here in silence, the room still, the night unfolding around you, remember this: you are floating in a sea of memory. The chair you once sat in, the songs you once sang, the people you've touched, their gravitational influence, their electromagnetic pulses, their energetic presence, each has nudged the cosmos. And in turn, you have been nudged too. Gently, subtly, forever. What if memory isn't something that fades, but something that shifts forms? What if the past doesn't disappear, but echoes through new structures, like a melody rewritten in another key? Maybe the universe doesn't forget. Maybe it recycles. Maybe everything that was becomes something else, layered into the curvature of time and space. You've walked through this world, and the world bent in response. Light scattered from your skin. Atoms responded to your warmth. Your footsteps pressed gently into the curvature of Earth, which presses back into the gravity of the galaxy. Nothing you've done is isolated. Nothing you've felt has gone unnoticed by the laws of physics. Every experience ripples outward, nesting within the grand geometry of everything. This is not a metaphor. It's the logic of the universe. A continuous unfolding of what was into what is. A quiet preservation of presence. A soft accumulation of being. You are not forgotten, because forgetting would require erasing the curves of space, the paths of light, the interactions of fields. And the universe does not erase. It evolves. As you settle deeper into rest, let's turn our attention to something extraordinary: life itself. Life is a remarkable pattern in the universe. It's more than molecules and cells. It's the ongoing dance of energy and information, organized in ways that seem to defy chance. And within that dance lies a new kind of memory, a living memory that may ripple beyond the individual. Every living creature is a collection of patterns that persist through time. Your body renews its cells constantly, yet the essence of who you are remains. That continuity depends on information, genetic codes, biochemical signals, electrical impulses in the brain. These are records. They carry history. They carry identity. But what happens when life ends? When the heart stops, the cells cease to function, and the consciousness slips away. The physical form fades, but the influence does not vanish completely. Your interactions with others, the energy you shared, the changes you caused, these continue. They are woven into the fabric of the world around you. Think of a tree in a forest. When it falls, it changes the sunlight reaching the ground, the flow of nutrients in the soil, the habitats for animals. It leaves a legacy, life imprints itself on the environment, and in turn, the environment shapes new life. This cycle is memory in motion, life remembering life. Consciousness, too, may be part of this cosmic memory. Though we don't fully understand what consciousness is, some theories suggest it's deeply linked to information processing at fundamental levels. If so, your thoughts, feelings, and awareness may be threads in the universal tapestry. Your attention, your intentions, your experiences may ripple outward, subtly influencing the world and beyond. Across cultures and ages, humans have sensed this connection, that we are part of a greater whole, that our lives echo through time and space. Science now offers glimpses of how that might be true. Through biology, quantum physics, and cosmology, we see that life is not isolated. It's a network, a system embedded in the universe's memory. So as you breathe gently now, feel yourself as both unique and connected. Your presence matters. Your life has shaped the cosmos, just as the cosmos has shaped you. Nothing you have done is lost. It lives on, in the atoms, the light, the gravitational fields, the memories of others, and perhaps in the very fabric of reality itself. This is the gentle truth. You are remembered, not just by those who know you, but by the universe itself. Your life is a story written in energy and information, carried forward in the silent song of existence. While the universe remembers all that has been, it also carries the seeds of what might be. Every choice you make today sends ripples forward, echoes that may shape moments yet unseen. Physics tells us that time is not simply a river flowing one way. Instead, it's a landscape where past, present, and future intertwine in subtle ways. The quantum world hints that possibilities exist simultaneously until observed, and the cosmos may carry traces of events that have yet to fully unfold. This means your intentions, your actions, your presence are not isolated points, but part of an ongoing wave. Like tossing a stone into a still lake, the ripples spread beyond your immediate sight. The universe records the throw, the splash, the pattern of waves, even if you don't watch them directly. In this way, the future may already be imprinted in the present, waiting to bloom. Your life, your energy, your choices, all contribute to this unfolding memory. The universe remembers not only what was, but also what could be. This idea offers a gentle comfort. You are not adrift in a random sea of events. You are an active participant, a creator whose influence extends beyond now. Your presence matters deeply and quietly. Consciousness remains one of the most profound and elusive phenomena in science and philosophy. Despite centuries of inquiry, we still lack a definitive explanation for what consciousness is, how it arises, and how it interacts with the physical universe. At the intersection of neuroscience, quantum physics, and cosmology, emerging theories suggest a fascinating possibility. Consciousness might not be confined to individual brains or isolated systems, but could be an intrinsic feature of the universe itself. In this view, consciousness might be deeply entwined with the universe's ability to store and preserve information, a kind of universal memory. Exploring this idea scientifically requires us to delve into multiple disciplines, from the physical basis of information to the nature of awareness. The hard problem of consciousness, as philosopher David Chalmers famously called it, asks, how do subjective experiences arise from physical processes? Neuroscience has made great strides in mapping brain activity correlated with thoughts, emotions, and sensations. Yet the subjective quality of experience, the what it feels like aspect, remains a mystery. Traditional physicalism, the idea that everything about the mind can be explained by physical processes in the brain, has struggled to provide a full account. Some theories approach consciousness as an emergent property, something that arises when complex systems, like neural networks, reach a certain level of organization. While this explains how information processing can generate behavior, it still does not explain subjective experience. Other approaches explore the role of quantum mechanics, the branch of physics governing the smallest scales of reality, in bridging the gap. One critical clue lies in the concept of information. In physics, information is not just an abstract idea, it is a physical quantity with measurable consequences. The laws of thermodynamics, quantum mechanics, and relativity all recognize the fundamental role of information. For example, Landauer's principle states that erasing information requires a minimum amount of energy, linking information directly to physical processes. In quantum theory, the state of a system encodes all the information needed to predict its behavior. This information is preserved even as systems evolve, suggesting that the universe itself operates like an enormous information processor. Physicist John Archibald Wheeler famously summarized this idea as it from bit, the notion that everything physical arises from underlying bits of information. If the universe is fundamentally informational, then consciousness might emerge from the organization and processing of that information. This implies a shift from viewing consciousness as a byproduct of matter to seeing it as a fundamental aspect of reality, embedded in the fabric of space, time, and energy. One prominent theory connecting consciousness to information is Giulio Tononi's Integrated Information Theory, IIT. IIT posits that consciousness corresponds to the amount of integrated information a system can generate, quantified by a measure called phi. Systems with high phi have a high degree of interconnectedness and cannot be decomposed into independent parts without losing essential information. The human brain, with its dense and complex network of neurons, exhibits a high phi, which might explain its rich conscious experience. More intriguingly, IIT suggests that consciousness could exist in varying degrees in many systems, depending on their integrated information. While IIT primarily focuses on biological systems, it opens the door to thinking about consciousness as a widespread phenomenon, not limited strictly to brains, but potentially present wherever information integration occurs. Quantum mechanics introduces phenomena that challenge classical intuitions: superposition, entanglement, and wave function collapse. Some researchers have hypothesized that quantum processes might play a role in consciousness, although this remains controversial. Roger Penrose and Stuart Hameroff proposed the OR, orchestrated objective reduction theory, suggesting that quantum coherence within microtubules inside neurons could facilitate non-classical processing integral to conscious experience. Although empirical support is limited, the idea highlights the potential for quantum information processing to underpin consciousness. Quantum entanglement, in particular, provides an intriguing perspective. Entangled particles remain correlated regardless of the distance separating them, implying a non-local connection. If consciousness involves or leverages quantum entanglement, it might transcend conventional spatial and temporal constraints, hinting at a universal, interconnected aspect of awareness. The notion that the universe itself may possess a form of consciousness, or proto-consciousness, has ancient philosophical roots, and has been revisited in modern scientific discourse. Panpsychism, the philosophical view that consciousness is a fundamental and ubiquitous feature of matter, aligns with this idea. While controversial, panpsychism challenges reductionist views and suggests that even elementary particles might possess primitive forms of awareness or experiential qualities. If the universe is conscious in some way, then our individual consciousnesses might be expressions of this universal mind. This view finds some resonance in contemporary physics. The holographic principle, for instance, proposes that the description of a volume of space can be encoded on its boundary surface, like a hologram. This implies that the universe's information content, and thus potentially its awareness, is encoded at a fundamental level, accessible from different perspectives. Memory, in the physical sense, is the retention of information about past states of a system. In biological organisms, memory manifests as stored neural patterns. In physics, memory can be found in the stable configurations of particles, the imprint of past events on cosmic structures, and even in quantum states. One example is the black hole information paradox. Initially, black holes were thought to destroy information about the matter they consumed. However, developments such as the holographic principle and Hawking radiation suggest that information is not lost but preserved on the event horizon. This means even in the most extreme environments, the universe retains memory of past events. If consciousness is linked to information, then memory is crucial. Conscious experience inherently involves retaining and recalling information about previous states, whether sensory, emotional, or conceptual. This creates a feedback loop between present awareness and past information. Connecting these ideas, consciousness can be considered a process that both reads from and writes to the universe's information store. It integrates information across multiple scales and times, creating a continuous narrative from discrete moments. On the smallest scale, quantum events leave indelible imprints through wave function collapse and entanglement, forming a distributed memory. On larger scales, neural systems organize information to produce subjective experience. On the cosmic scale, space-time and matter encode histories of interactions. Consciousness, therefore, might be understood as an emergent phenomenon arising from complex information processing, deeply embedded in universal memory. Our minds do not simply exist in isolation, but participate in a vast, interconnected system that records and evolves information through time. This perspective has profound implications for how we understand identity, free will, and the nature of reality. If consciousness is fundamentally tied to universal information, it suggests continuity beyond individual lifespans and opens new avenues for exploring collective awareness and interconnection. Yet, there are significant challenges. Empirically testing the relationship between consciousness and universal memory requires tools and theories beyond current capabilities. The subjective nature of experience resists straightforward measurement, and quantum effects in biological systems remain an open question. Moreover, bridging the gap between microscopic quantum events and macroscopic conscious experience is an ongoing challenge. How do the probabilistic, non-local properties of quantum mechanics scale up to the unified sense of self we experience? Science continues to advance toward understanding consciousness not as an isolated phenomenon, but as an intrinsic part of the universe's informational fabric. Consciousness and memory may be two sides of the same coin. The active process of awareness intertwined with the universe's capacity to retain and transform information. Though much remains unknown, this framework offers a compelling vision of how the universe remembers itself through conscious beings. It unites the physical with the experiential, the microscopic with the cosmic, and invites us to see ourselves as participants in a vast, ongoing process of information integration and preservation. In this light, consciousness is not simply a byproduct of matter, but a fundamental aspect of reality. a universal memory written in the language of information, unfolding across space and time.